Welcome to a new episode on my Weidmüller automation controller series. Previously, we looked at how you can program the automation controller under Node-RED, but we haven't really spent any time on visualization and what you can do within Node-RED. And this episode, we are going to do that. So we are going to look at what are the visualization and the dashboard capabilities within Node-RED, and actually how you can build something like this. So as you can see on the screen, we are going to learn how you can set up some basic controls, for example, push buttons and also switches, how you can use some screen controls in order to show states, have various input parameters, for example, a slider to control something, and also use some of the built-in gauge and graphing functionality. And besides this, I'm also going to spend some time showing you how you can build layouts and floor plans using some of the special controls that are available as separate nodes. And since we are talking about UI and visualization, I also want to spend a little bit of time talking about some of the built-in nodes that are available. If you have scrolled down here, you could see that there is a section about operating system. And with these operating system nodes, you can set up a very simple monitoring of your Weidmüller automation controller. So you can see that the general system parameters, what are the CPU load, what is the memory consumption, how much storage is available, and also how much storage is available in the SD card that you can put into the automation controller. So this gives you a general maintenance of the underlying CPU and the memory within the automation controller. Before we start diving into the functionality, I want to mention that this is not the only visualization option available in Node-RED, but this is the one which I think it's used the most, and it's called the dashboard. It's a separate component that you can install, and that gives you all these visual buttons and various controls that you can see on the screen. And this particular drawing that you can see here on the left is provided by yet another different component. So just to reiterate what we have learned previously, if you want to install a new component, you click in this, somebody told me that this is called the hamburger icon, and you select Manage Palette. And in the install, first you search for dashboard. And because I've already installed, actually it's here, it's the Node-RED dashboard, and at the moment it's 2.22.2. So it's a fairly big addition to the Node-RED, and it's going to take probably a couple of minutes to fully install. So just be aware of that. And the other one is this one, the Node-RED Contrib UI SVG. So that's the vector graphics component within the dashboard that we can use to build various floor plans and other options. Once you install these two components, and if you start scrolling in your catalog, then sooner or later you will find this dashboard group. And as you can see, there are so many different nodes that are available here. So we can have buttons. These are the turn off and the turn on are the buttons. We can have drop downs. I haven't used drop downs, but these are the classical drop downs. You can have switches that you can see here that I'm controlling the output 7 with. You also have various input fields, out of which I'm using the slider here. But you can have simple numerical input, text input, date picker, color picker, or even you can have forms which basically use the combination of these two. So those are the various input nodes that you can use. And then you can have a lot of display nodes. So you can display text, which can display, well, as it says, text or any other value. So again, if I refer back, these are the for example, the one which shows the current value or the current pressure. These are the text controls. You can also have gauges that you see here. So this is the pressure gauge, but this can have different appearance as well. The next one is the chart. Again, I've used the chart here, so you can see a very simple example chart. But again, this can do a lot more, and you can have bar charts and light charts and I also have a few other components that I'm not going to use. So it is possible to create an audio out. So that would be a component that it can play an audio or a text-to-speech on your dashboard. So anyone who is viewing the dashboard can hear that, either that spoken command or maybe a music or something. Notifications, that's something that we are going to use. So these could be like balloon notification that come up on the top right, so give you some visual alert that something is happening. UI control is again something I'm not going to use. So this could be used in order to move across various tabs. As you can see, I have two tabs, the home and the system at the moment. So this is more for sort of like forced navigation or control navigation. And the template node that allows you to create custom controls. For example, these words here which says on and off, those are created by this template control. We are going to dive into that a little bit later. And the SVG graphics that allows you to create a vector graphics within the dashboard. So this is all the controls that are available in the dashboard, and all the code that I'm going to show here I put into this new dashboard flow, and at the end of the video I'm going to export this flow, and you will find the link to this flow in the video description. And before we dive into the details, I just want to give you a really high level overview of what the dashboard is. Well, dashboard is something that you can see here. You will always be able to access it using the URL or the IP of your device /red, that's for Node-RED, and /UI. So that's the URL for the UI. And what you see here is you see this top banner, which is always going to show you on which page you are. And then if you click on these three lines on this hamburger icon, you can see the various pages. So at the moment I have two pages. One is the home and the other one is the system. So this could be, completely separate pages. And within each page you have groups. You can see this is one group, and that's the second group, the third group. And you see a little bit of difference between the background. So the background is a very slight gray color, and the groups have a white background. So you can see the dividing lines between the two. And the way this screen look like is that you can specify the order of these groups, and you can also specify how wide each of these groups are, but the placement, how they appear either next to each other or under each other, it's always determined by your screen layout. So if I take this screen and if I make the screen a little bit narrower, for example, if you would look at the same page on a mobile phone, then you only be able to see one group at a time. So all the subsequent groups will appear under each other. You will be able to see all, for example, 4 groups next to each other, but that would always depend on your screen resolution. And this is the basic principle behind the whole dashboard. Actually, it is very simple. And once you install the dashboard, you come here to the right to this tab, you also find this new option here, which is the dashboard. And here you can see the different tabs that I mentioned, so the home and the system, and within the tab you have the groups, and within the group you have the various controls, and you can just move them around. So you can drag if you don't like the order, or if you want that group to be the first, you can just move it around, and that's how you also control the sequence and the layout on the screen. And each of the group has a width, so the standard width is 6. As you can see, the SVG graphics is twice the size. If I go back to the home, you can see that that's the standard 6 width, and this is 12 width. So these are the basic controls that you have in order to control the layout, and everything else is done automatically, which is, sometimes it's a little bit of pain because you have to play around with the width in order to make the screen look like the way you want. But on the other hand, it really adapts easily on the various devices that you're using. So it's going to look okay on a mobile phone, on a tablet, and also really high resolution laptop screen. Okay, so the first thing that we are going to control is this really simple 2-button control. And here we are controlling out 8 of the first digital output card. And as you can see, I have a button for turn on and I have a button for turn off, and the current state is also indicated here. So the word changes from on and off, and actually the color of the text also changes. So if you can see, you would be able to see that the on is actually green and the off is gray, but the colors are so close to each other that, well, it doesn't really show on the screen. So let's see how it created in the flow. So first of all, I'm using the button controls. So I just move it here. I created 2, one for the turn on and the other one for the turn off. And actually it is really simple. Well, first of all, you have to specify what the group is. And if you want to create a new group, you just select here the add new group. But otherwise, within the group, as I said, you specify what the title of the group is, which page or which tab the group is on and what is the width of the group. And on the page itself, again, you just specify a name and you specify the icon. As you can see, my home is like a home icon and the system is sort of this graph icon. And once you have assigned the group, then you can specify the size of the actual control here. You can have a separate icon on the button as well, and you just have a text of the button. You can have tooltips, background color, foreground color, but more importantly, what you specify here, that when this button is clicked, what should be the topic and the payload of the message that gets sent out. And I wanted to do it really easy, so I just said my payload is going to be 1 for turning on, and it's going to be 0 for turning off. So I wanted to replicate the scenario that we have discussed previously, that we are using ones and zeros to turn things on and off. And as we know, the IO out node expects a specific payload. So for on, it expects the value equals to, or the value being true, and for off, it expects the value as false, as a JSON. So all I have done is the message that comes out of these buttons gets converted to these JSONs, and I send it into an IO data out, which is set to change the global variable out8. And as we know, this is the 8 output on the first output card. Again, I haven't set up the camera, but I think you can believe me that the actual value or the output actually changes. And what I've also used is I've also used the output of this node to also show on the screen that the output has actually changed. So as you can see, when I click on turn off, this changes to off, and when I click on turn on, this changes to on. And this is the template node that I mentioned previously. So the template node is here. And what you can do here is you can specify your own HTML code, what should be part of the UI. And this could be used in a lot of different ways. So you can use this to embed images to your dashboard, or you can even create a small iframe, and in that iframe you can embed a different web page. So there are some really good uses for this template node. But in this example, I'm just going to keep it simple. So as you can see, it shows what the current state is, as text current state, and then it either displays an on or an off. And as you can see, I have put a small bit of JavaScript code which says if the message.payload.value is the word true, then it's on, otherwise it's off. And also if it's true, then the color is green, otherwise it's gray. That's why it has this look that I just mentioned before. And actually it is that simple. So this is how easy it is using buttons to control output on the automation controller. So the next example is how to use a switch. Well, it's almost as simple. So we use the switch node, which is the third one. And here the switch node is a slightly bit more complicated. Again, with any UI control, the first thing that you need to specify is the group, specify the size, you have the label just like before, you can have tooltips and icon as well. And because this is a switch, you specify the on payload and the off payload separately. I mean, the topic would be the same that I haven't even specified. But here I use the opportunity to specify the actual value that the IO out node expects right here in the payload. So I just specify that it should be a JSON, and the value is this for the on, and that's the value for the off payload. And here, because I'm already sending the data out in a format that is expected by the IO data out, which is using out7, I didn't have to do anything. So I just basically wired the two together. And here I wanted to use a slightly different method of displaying the output. So instead of taking the output and putting it into this template node, which is actually here, I have used an IO data in, which is also pulling out 7 every second and is displaying the result. Hopefully you can understand that with the first example that I have shown you, the output is going to reflect what I have set from the UI, because if any other process changes the out7, the IO data out node is not going to generate me a new output showing me that the output has changed. For that to happen, you have to use this example. So you have to use an IO data out to set the value and an IO data in to get the value, which means that if this output is changed or if this global variable is changed from any other source, at least you would get a notification of that in Node-RED. And again, the principle is very simple. You can switch and it changes on. And as you can see, because the 1 second refresh date, the change on this field is not instantaneous. And if I change it off, then it switches off. And actually I can see the LEDs coming on and going off on the automation controller visually as well. So it is definitely working. Very simple. Next one is slightly bit more complicated. These are the graphs, but actually that's going to be very simple as well. And for this, I'm going to use the pressure sensor. So let's look at the code. It starts to look a slightly bit more complicated. By the way, if your flow is too big, you can zoom out like this and it just basically gets smaller. So we start with an IO data in node, which is set to the pressure variable and it's polling it every second. And then first of all, I'm getting rid of all the different values and I'm just replacing the payload with the message.payload.value in a number format. This is something that I've already described in the previous video. And what I'm doing here is just feeding into this graph node. And this graph is, as you can see, I named it pressure history. I set it to a line chart. And here, the really nice and convenient thing about this chart is that you can specify how much data the chart should keep. Because you can just simply send data in and the chart would automatically assign a timestamp to the data when the data was received, and it would just automatically start collecting the data, and I told this chart to keep the data for the last hour. So anything which is older than 1 hour, it's just basically going to disappear from the chart. So as you can see on the UI, data is being fed in from the right, and so that's basically now. You can see 22:50, which is the current time at the moment, and the first data on the left is 1 hour in the past. And this is why I'm saying that it is so easy to use this chart node. I really like it. So in the axis you can set it to remember for the last how many seconds, minutes, hours, days or week, or you can actually specify points as well. And you can also set how the X label should display the time. And the other nice functionality that this chart is able to display multiple data points. And these are the colors of the various data points, and we are just going to see how that works. One thing I haven't mentioned is this change topic. And as you can see, the only thing I have done here is I set the message topic to the text live data. You can see that as I hover over the chart, I'm getting this tooltip which shows me the actual value. I mean, I have too much data here, so it's hardly visible, but you can see that the live data is 102. So that's the thing which is coming through this line. Because what I'm also doing is that I get the pressure value and I fed it through the same logic that we again used previously. So I have this function node which collects the last, I changed the history size to 50. So it collects the last 50 readings. It feeds it into this aggregation node, which calculates the aggregate value, and that changes the topic of average data. And that also goes to the history graph. And this is why when I hover over, you can see that there are actually two data points. The green one is the live data, and the orange one is the average data. Sorry, not green, but blue. And the average data is actually there, but the blue one is just overriding it because it goes up and down so much. So here we can see the live pressure value, and we can also see the average of the last 50 reading. But what else I'm doing with this data? I'm also feeding the same data into this gauge, and that's the one which is displaying this half donut or a half arc shape. You can specify whether you want a gauge or a donut or a compass or a level. I'm using gauge most of the time. You can also specify what is the value. Here in the value format, you can remove decimal places, and you can also set the unit. So it actually shows that the unit is millibar. It is not actually millibar, but I wanted to add something for the demonstration. And you can even specify a range, and that gauge, that green stuff, would automatically auto scale or auto color based on the pressure value. So a minimum 50, maximum 500. And yeah, this is all you need to do. You just need to feed in the data and it would automatically display it. And again, the history just automatically keeps the history, deletes the old data based on your settings. You don't have to do anything. And just to show you another example, I have also created this simple text node. So this is this text output, which it just says current pressure, the word current pressure, and next to it, it is displaying the message.payload. So the value that is coming in through the message.payload, and it just puts the millibar as a unit next to it. So this is why you see the value here as a simple text as well. So 3 different ways to visualize the same data. And let me play around. Oh, before I play around with it, let me also show you what else I have done. It is possible if you send in an empty array into the chart, then the chart gets reset. So if I do that, now you can see that the chart gets reset. And now you can see how it starts, storing the data. So, and it would just keep doing that until, 1 day worth of data is, 1 hour worth of data is collected, and then it just start, losing the data on the left. So that's good. And what I'm also doing is, once the raw data comes out, it goes to the switch node, and I say, if the payload value is greater than 500, I create an alert, which the alert has a topic, and it also has a message which says overpressure, and then message.payload millibar. So it's basically concatenating a piece of string together, which has the word overpressure, and then it has the pressure value and millibars at the end. And this information goes to this notification. And I've set it here that the notifications should appear on the top right of the layout and then stay there for 3 seconds and automatically disappear. So let's see how it all works in real life. So I'm just going to remove the cap from the pressure sensor, and I'm going to apply some pressure. By the way, now you can see how nicely the live value and the last 50 average shows that it's a much more constant value. So now I'm going to apply some pressure. And now you can see the live data going up. And then slowly but surely the average is going to follow as well. And if I apply more pressure, more than 500, we should see the notification as well. And that's the notification. And well, that's going to trigger every single second as soon as the pressure is over 500. So we are going to see that quite a lot. And if I let the pressure go just a little bit, as I said, let the pressure go, then the notification will stop appearing. And now you can see that the pressure is reducing. And then hopefully after a while, the average is going to drop with it. I would say this is very simple and very powerful visualization. And as you can see, we have done it just with a few nodes and with basically just wiring the data and, to some extent, changing the data format to suit all these different UI nodes. Let me jump a little bit and talk about this pressure threshold here. And for that, I have actually modified one of my previous values or one of my previous flows. And if I go back here and if I go to the program, hopefully you can remember that from the second video, that I have this piece of program, which is switching out 4 based on the pressure sensor value, but it does a little bit of hysteresis just to make sure that the output doesn't get switched too many times. And I have done a small modification to this code because previously you might remember that I had a local variable which was called the limit or limit value. that doesn't exist anymore, because what I have done is I've changed that to a global variable. So now we have a global variable which is called the limit value, and I have done that so we can control the limit value from the UI itself. So if I go back to the UI, now you can see that my limit value is 145, and here in the real-time applications, or in the program, you can also see the limit value of 145. If I go to the UI, I drag this to 175, you can see that it gets updated as well, and now it's 175 as well. So again, really good and simple example how you can interoperate between the function block programming and also in Node-RED. And that also uses the pressure sensor. So what I can do now is I can increase the pressure again. And then once the pressure goes over 175, you can see that the output turns on. And here in the UI, I can also see that the output turns on. And I have done all this using this very simple flow. So I've created an IO data in node, which is getting the limit value every 2 seconds. Next, I'm getting rid of all the object, and I'm just creating a simple payload with the message.payload.value in a number format. And I'm feeding that information into my slider. So this is the slider itself. And here in the slider, I have specified that it should have a minimum and a minimum of 100, maximum of 200 with the steps of 5. And the reason I fed the value in, because again, if this global variable gets set from any different place, then at least my UI should automatically update to show that. And of course, if the slider value changes, then it outputs the value in the output port of that node, which goes into this change node, which just reformats this data into the JSON format that is expected by the IO data out, which is going to write that value into the limit value global variable. And in order to show the current state of the output, which we are controlling, I've created yet another IO data in, which is getting the out 4 every 2 seconds, and it's feeding into this very same template node that we have used in above as well. And last but not least is this furnace room example. And please excuse me, but my drawing skills are really limited. What I wanted to simulate here is how an industrial HMI looks like, that it usually contains a stylized drawing of your shop floor or your furnace, or basically whatever device that you are trying to control. And this is what I wanted to mimic here. So this bar here, which is this has this gradient fill, it's supposed to be a pipe, and then the pressure on this pipe is being displayed here in this green background. And you also have a pump, which is represented by this arrow. And because this arrow is sort of like a gray color, it means that the pump is off. And if I press a button, a physical button, then the pump gets turned on. So now the pump is running and it changes to green. Very simple, but again, it shows that you can place various visual elements and text on, let's say, a map, and you can map it to real values, global variables, inputs or outputs of your automation controller. But let's see how it is all done. It's going to be a little bit more complicated than previously. So there are two things that I'm using for this. First of all, I need the pressure value. So as you can see, it's really the same value that we have seen here in the graphs and also in the gauge. So all I have done is, again, I've taken another line here, and in a change node, again, I had to change the data just a little bit more. And this is going to make sense when we look at the actual graphics and the configuration of that graphics. And the other thing I've done is I also wanted to show the state of the pump, which is actually the out2 output, which we have already used in the previous flow. So I wanted to take the opportunity to show you another node. You can see these link nodes. If I search link, you can see there is a link in and a link out. And the whole purpose of these nodes is you can create links or wires between flows. So what you can see here is that this link out, sorry, that this link in, you can see that's how the link in looks like, is connected or virtually connected to a link out, which is on another node. So you can see here I have the IO data in. So the data comes through here, it goes through the change node and the RB that we have discussed previously, and then it goes to the counter, but it also goes to this link out, and on the link inside I have specified that, you know, these two links are connected together. So the data that comes through here magically appears on my another flow here. And you can use this link in and link out to link data from, or link points of your flow in between different flows, or you can also use them if you need to send data from the top of your flow to the bottom of the flow, and it would be, you know, physically complicated to wire them together, or you have to use a lot of wires and it's just going to make your flow look really, really messy. You can just use these link in and link out nodes. So here we have a data which is coming in, and that data is going to be a 0 or a 1, whether that output is getting switched on or switched off. And that I'm also converting again to a different format. And that format is going to make more sense once we go into the SVG graphics node. So this node is what you see here. So that is displaying these stylized pipe and the readout and the pump symbols. And if I double click this node, then as you can see I specified it to have a size of 12 by 7. And what you do first is you can click on this Open SVG editor, and I'm not going to go through this, but that's how you can create all these drawings. So you can have various elements here, so you can create primitives like circles or rectangles, or you can come here to shapes, and in here from the font awesome icons you can pick up all sorts of icons to represent. And for example, I think I use this for the pump icon. So this is my pump icon, and if I go into the properties, oh sorry, not this one, that's my pump icon, and if I go into the properties, it has an ID of pipe icon, and it has a certain color, and also I have the text which is showing 234 at the moment. And again, if I go into the properties, it has an ID of pressure text. So I draw all these elements, and then what I'm going to do is I'm going to refer to these elements from my flow. So I'm going to close the editor, and I'm going to go here which says input bind, which you specify how the input message is getting linked to any of these visual elements. So if the input message contains a payload.pressure attribute, then that value goes to the pressure text, that's the ID of the text which shows 234, and then it changes the text value. So that's why I'm getting the pressure value updated here. And similarly, if I receive a message which has a payload.pump attribute, then I change the pump icon fill attribute, which is the fill color, to a different color which comes through. And now we have done that, we will understand why these change nodes are required. So as you can see, the payload here is an object which has a pressure attribute, which is the pressure value converted to a text. So again, if you remember, the pressure value comes through here, so I'm just converting that data, the simple number data, into an object with the pressure attribute, and the value is the pressure value as a text. And I'm also setting the topic to have a value of data bind, because otherwise the message will get ignored. So that's how I'm updating this pressure value here. So this is why it gets updated every single second, just like these ones, because of these flow. And then when I operate the switch, then from my first flow we are getting a 0 or a 1, whether the switch is on or whether the output is on or the output is off. And if the output is off, then I'm again creating a payload which has an attribute pump, and it has the word silver because this is the name of the color, the gray color. And again, I'm setting the topic, the data bind. So this node knows that it needs to execute the input bind based on these binding source and selector and binding destination settings. And if I want to turn it on, then I want to change the color to green. Well, not green, but teal. So I'm setting the payload to a pump attribute and the teal value. And again, the topic, the data bind, and I send this data in. And that's it. I know this is a little bit steep, especially the SVG part, but I have to say there is so much potential in this SVG component. And if I come here and if I look for this SVG, sorry, let me do it here, SVG. If you click on this icon, then it opens up the page for this component. And this is absolutely massive. And you see an introduction to what SVG is, because besides this really nice editor that you can use here, if you are really hardcore, you can edit the SVG using the XML data. So, you know, this is the hardcore way of doing that. But you can read all about this here. But of course you can ignore that because there is the editor. It also tells you how you can use the editor. And actually it also tells you somewhere here that there are third-party editors. So for example, if you want to use it for a home automation and you want to create a nice floor plan for your house, there are separate, it's almost like an image editor applications that is going to give you a really nice floor plan. And there is one thing that I haven't explained here. You can also create clickable components here. And when you click on them, it will automatically generate events that are going to be sent out on the output as messages. But I think, you know, doing this that I've done is probably going to be enough for a beginner. But as you can see, you can define events like clicking, double clicking, mouse over, mouse out, well, pretty much everything you want. So this is why I said it's absolutely massive. There is so much potential in this SVG node. There is loads of functionality in here. And I think there is at some point that it talks about the various animation that you can also do. So here, oh, look at this. So yeah, lots of stuff. And with this, we reached the end of this dashboard. But before I finish the video, I also want to talk about this system monitoring. So within the standard Node-RED installation, there are these components in the operating system: drives, uptime, CPU usage, loads, and network information. And actually for these nodes, there is a sample flow that I've used on my other Node-RED system as well. And I've just imported the same here to the automation controller. And so this is not even my flow, it's a sample one. The only thing I have added is I have these drive or the storage data that you can see here, and that storage data appears on the UI. For example, you can see the storage, so that's the main storage, and also the SD card. So that's the main internal storage of the automation controller, and this is the SD card that you can insert separately into the automation controller to store files. And to be honest, this flow uses the same gauges and graphs that I've shown you before, so I'm not going to spend any more time explaining this. But you will find the link to this flow as well in the video description. And I think this is a great addition to any Node-RED system. But that would be all on the visualization capabilities within Node-RED. Just like previously, if you have any questions, just ask them in the comment section below, and I will try my best to answer all of them. Thanks for watching, and hopefully see you in the next video.